All right, class, you know what to say.
Morning, e-learner.
That was weak. Try one more time.
Good morning.
It's a Thursday. All right, good morning, e-learners.
That's you to pretty sharpie.
What?
It's you to better than us.
They're part of the class, so let's welcome them. All right. We are done with chapter 1, the easiest chapter of the book. For the e-learners, we just went over the corrections of the test. Obviously, I didn't want that on the video. Since you are taking your test, or actually, no, when you watch this video, that's all done. But I guess I could have recorded that part because you would be taking. All right, so it looks like, what, in 8, 9, 10 days, we got a holiday. Yay. Labor Day. Labor Day. So another full week of class, quiz on Wednesday, and then we have a 3-day weekend. All right. So, hey, we're starting 2.1 today. All right, here is your, turn this on. Here is your homework. Please copy it down. I'm listening. Yes. Doesn't say that. Yes. Yes, you may. You guys need to be a bit more efficient on copying down stuff, right? Because I'm going to click the slide right now. All right. So we are moving on to, okay, chapter 1 was the easiest one. This one is more medium. Some of you will be able to do this without any instructions. Others of you will need a lot of instructions on this. For those that haven't been exposed to any algebra, this can be a little bit challenging. All right, so it's got a nice friendly title, Writing Mathematical Expressions. Sounds easy, writing, right? And I will say that in the big scheme of things, I will see lots of mistakes on this, even though I'll have kids say, oh yeah, I get that, I understand it. There are a couple points here, places in the lesson here where I will point out this is where everyone makes their mistake. When I get to that, that's when you absolutely positively, you better write stuff down and pay attention. For the most part, most of the students I get when I teach this, this instruction doesn't faze anyone. All right, so writing, I'm not sure why that's down there. Writing variable expressions. Oh, I know why, because I didn't make it animated. So here's the big scheme of things. I'm going to give you a phrase or a sentence. Are you listening? I'm going to give you a phrase or sentence. You're going to write what the math would look like. In other words, you're going to write something like this from some words I'm going to give you. I'm going to give you some words, English words, and then you're going to write the math words. The math words are, as indicated right here, that 3 plus 2. Okay? So I will give you a phrase or sentence. For instance, my phrase or sentence might be something like 2 more than 3. Right? Are there any math symbols in this red portion right here? No, right? It's all English words. Your job today is to take this and turn it into this, right? And like I said, most students are like, okay, I can do that. I will just say this is a couple times where we'll see lots of mistakes. Question? How did I miss you? You were sharpening your pencil or something? Okay. Oh, okay, so recall. We have these things in math called math Operators. Math operators are a big fancy word for, I will insult your intelligence, addition. What's the symbol that we use for addition? Yeah, that little thing right there. Yes, I am wandering aimlessly about. We have a word called subtraction. The symbol is? Okay, am I insulting your intelligence? Hopefully I am, right? The symbol for multiplication is? Can be lots of things, right? For right now, for this class, right, I don't care. You can use the dot, you can use the straight-legged X, not the variable X, or you can use parentheses. I only put this because I want to make this a little bit easier. And lastly, division is? The division symbol. We will also, yes, we will also this year start seeing the fraction bar for the division symbol. By next year, we will never see that symbol again, ever, in math. By next year, in pre-algebra, we switch from using this symbol to the fraction bar. Why? Because you do some really crazy division from pre-algebra on up, like really long. I don't mean long division, but I mean where you're dividing your divisor and your dividend are very, 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 very long numbers. Yes. Yes. So for most of you, you're like, yeah, duh, I know that stuff, right? All right. Her mom's in jail. Okay. If you don't know what that means, then consider yourself lucky because it's crazy. All right. So the first thing we need to do in box one, notice how many boxes do you have in box one?
1, 2, 3, 4.
So the purpose of this lesson where we're going to take words and turn them into mathematical expressions. So we need to learn what the words are for operator, because this right here, that's the math operator, but there are English words for this symbol right here other than plus, right? There are other words for that symbol. Who can give me an English word that isn't addition or plus for that word right there? I said that word, that symbol. Addition is the word add. Give me another word for that thing right there that you could use in English language. Yeah. More than. I'll show you the list right down here in a second. What else? And 2 and 3 means 2 plus 3. The sum of 2 and 3. All of those are addition words. Let's write these down. These are kind of the, I don't know, maybe the more commonly used ones. Sum, total, more than, increased by. Absolutely, and is one of them as well too. Yeah. So in that first long box, just write addition or put a plus symbol and write these words. I tried to choose the words that they use tonight for homework. So if you see any of these words, they're telling you, hey, add. Total, sum, more than, increased by. Which leads us to what? Next box would be, there is, I call them the $10 words. These are like the 10-cent words. There's a $10 word, I mean, it's really special, right? That means subtraction, and it's not subtraction. There's a $10 word for subtraction. It begins with the letter D. What is it? What is it? Devise. Divisor, that's kind of more division. Decrease by is the 10-cent word. Do you know, or are you guessing? Difference. Write this down, please. Difference is the really special word. Most of the time, when we get to pre-algebra and above, they want you to subtract, they're going to say the word difference. Not always, but this is the special word that you will become familiar with this year. The other ones kind of come from the opposite of the addition words. Instead of more than, it's less than. Instead of increased by, it's decreased by. Fewer than as well, too. 2 fewer than 3 means 3 minus 2. If there is any operation you will get wrong, guess which one it is? Subtraction is the one that will kick your butt. And it's because of how we speak in English. I don't know why it's subtraction, but for subtraction, it's the one, and you'll see today, typically students get it wrong. It's not that they don't understand, yeah, I know I'm doing subtraction, but they put the numbers in the wrong order. You guys don't know negative numbers yet, but 5 minus 2 is not the same as 2 minus 5. They're two different complete numbers.
Isn't 2 minus 5 negative 3?
It is. But that's not the same as 5 minus 2, which is positive 3. Two different numbers. We do addition, 2 plus 5 is the same as 5 plus 2. Subtraction will get you into problems. Yes?
I learned this last year, and correct me if I'm wrong. It's like subtraction, like when you write 5 minus 2, that minus 2, isn't that like a negative number in some way?
In some ways, yes. In fact, this is one of the big confusions when we get to pre-algebra and algebra is because we start writing negative numbers as subtraction.
Oh, I already know this.
And we write 5 minus minus 2. I'm like, what? Don't worry about it. We'll talk about it at the end of the years when we do negative numbers. All right, multiplication. Anybody know the $10 word for multiplication? And it's not multiply by. And it's not the word times. What's the $10 word? Difference is subtraction. What's the special word for multiplication? You may have seen it before. Starts with the letter P. Go ahead.
Product?
Product. Write that down. Product. And yes, you will see the word times, but not the way you think. It's not going to say 5 times 2.
How many times?
It'll say 3 times a number. That means multiply by 3. Sometimes you might see the word double. Guess what double means?
Multiplication.
By
2.
triple.
3.
Okay, you got it. You got it. Anybody know the $10 word for division? Starts with the letter Q.
Quotient.
Quotient. Very good. All right, you guys got some skills. You got some knowledge. Those are the words that you're going to see today. Literally, all we're going to do is I'm going to give you a phrase or a sentence, and you're going to write the math expression. Of all of these, the one that will cause you problems is subtraction. The rest are kind of, they just exactly the way you read it or kind of the way you write it. The subtraction is the one you got to be very careful with. We okay? We got these written down?
No.
Write faster. The one thing that you're going to be doing in this school is taking lots of notes and doing it efficiently, quickly.
My hand is literally shaking.
All right, here we go. So you do not need to copy this down. If you're a step person, like, no, I always need steps to do something, well, here are some steps. Okay, I will come back. This will also be on every slide that I show you. So I'm not going to pause long for you to write down the whole thing. Step number 1. So remember, I'm going to give you a phrase or a sentence. You got to write a math expression. Step number 1 says, identify what you're doing. Hey, am I adding, subtracting, multiplying, or dividing? You're going to do that by identifying that operator vocabulary that you just copied down in box number 1. Step number 2, the easy part, find what numbers you're dealing with. I mean, literally like THREE, find the numbers. Step number 3, the hardest one that you got to wrap your head around for today is we're going to have variable expressions. That means there's going to be a variable. Sometimes they will literally tell you what the variable is. The variable t added to 10. Okay, 10 plus t. Easy, right? Other times, are you listening? They are going to say the keywords, a number. If you see the words, a number, guess what they want you to do? They want you to assign a variable. That's what this means. If you just see the words, a number added to 2. I don't know what that number is, so you use a variable. A number added to 2, 2 plus x. Make sense? Yes?
Do you want us to do the math too?
No, you will not do the math today. Last one is, okay, I know what I'm doing, add, subtract, multiply, divide. I know the numbers, I know the variable. Just push everything together, and you'll see how that works. Okay, I'm going to move on. If you haven't copied all this down, it'll be on every slide. The blue box is what we're doing here. A number increased by 3. So let's see. Let's follow my steps. Identify the vocabulary. A number, no, increased by. Oh yeah, that's in box 1. That's addition. So I put a plus. A number, well, a number increased by 3. Well, 3 is obviously THREE. That's the number. So I'm increasing something by 3, right? If I write 3 plus, are you increasing that by 3? You're increasing something by what happens afterwards. So check this out. If I wrote 3 plus, well, what I'm increasing by is what's in that box. If you want to write something increased by 3, it's not 3 plus, it's plus 3. Now I'm increasing something by 3. Does everybody see that difference? Right? Okay. Oh, those keywords, a number. Guess what I need to do? I got to assign a variable. So what letter you like? Okay, so you may choose any one of the 26 letters. I am lazy and I will always choose X. Okay, tonight for homework, anybody have their book open right now? Right? Do they tell you the variable or do they ask you to assign a variable? So sometimes they will literally tell you the variable they want you to use. 10 more than a number T. So they're saying use T. Okay, we good? All right. Which one did I say would kick your butt? And I said subtraction will kick your butt because the way that English is written. Literally read the first 3 words. 7 fewer than. Guess what you really, really, really want to write?
7.
Guess what you really want to write when it says 7 fewer than? I'm doing this wrong. I really, really, really want to write 7 minus. But just like with addition, what are you really subtracting?
Minus 7.
Whatever goes here is what you're subtracting. English is weird. It says 7 fewer than. You're going to really want to write 7 minus. Be careful. What you're subtracting is always to the right. Does you see this? To the right of the minus sign. Well, 7 fewer than, clearly we understand we're subtracting. And what we're subtracting would go to the right of the minus sign, not to the left. Technically, what's to the left is what you're adding, as long as it's positive. I'm getting ahead of myself by 1 year. Well, 7 is the number, and a number T. Hey, they're telling me the variable. What are they telling me to use?
T.
So the T goes there, and I'm done. What I would recommend, especially with subtraction, is that you look at your expression one last time and make sure it, in fact, says what you want it to say. Does it say T fewer, or does this say 7 fewer? Does what I wrote say T fewer, or does it say 7 fewer? It does. If I wrote 7 minus T, that would be T fewer. Subtraction will kick your butt.
Yes, it will.
All right. That's a lot of times, right? There's it looks like a multiplication symbol, but it's not, because it says a number X times 10. Take a guess. What am I going to write?
A box times 10.
Okay. It says a number X times 10. So clearly, what operation am I doing here? I'm doing multiplication, so a dot or parentheses. You can use the X, just be careful. Look what my variable is. I'm going to have X 10, right? You're like, what the heck's going on there? So maybe use a dot or parentheses so you don't cause that confusion. So a number X times 10. Make sense? How many people are not impressed? Okay. You shouldn't be, because this isn't really that challenging so far. See if you can do all of box 3 all by yourself. Guess which one is the hardest one? The very last one. All right, go. See if you can get this done. Who is completely and totally lost? I don't know what to do. Let me help you. No one? One person's lost? All right. All of them. Okay. 10 more than. Where's the operator words?
10 more than
Okay, so put a plus. Over here. We're doing box 2. I'm sorry, box 3. Okay. What are you adding here? You're already done now. I was walking you through step by step. Yes, you got it. Go. Move on. Do the next one. Okay. What? Well, where are you doing your homework from? Well, you're already using it. There you go. You answered your own question.
I did it.
All of them? All right, who's still working? Keep going. Anybody need help? It's not a lot of people needing help. That's a good sign. Yes, perfectly fine. You'll see me do that as well. All right, here we go. Let's start with, is Lily my go-to person to start with? Yes. Let's start with Lily. First one. What did you write?
I wrote H plus 10 because it says 10 more than 8.
Yeah, it doesn't say H more than 10. It says 10 more than H. So what are you really adding? I'm adding 10 because that's what 10 more than means. 10 more than means plus 10. Now, for those of you that wrote it backwards, well, that one math property called the commutative property saves your butt because H plus 10 is the same as 10 plus H. But I'm saying Lily had it right. The way it reads, it should be H plus 10. Good job. All right, Matt, next one. Did you use the division symbol or fraction bar? You can, right? K divided by 2. Somebody over there used fraction bar. K over 2. Perfectly fine. Nick, you got this one?
6 times x.
How'd you write that?
6 dot x.
You wrote 6 dot x? So did I. All right. And Kira, you got the last one? Hardest one? Don't you really want to write 12 minus g? Yeah? I mean, no, I'm saying as you read it, don't you really want to write 12 minus g? All right. Let's take a look. What does 12 less mean? No, her answer. What does 12 less mean? It means subtract what? When you say 12 less, what are you subtracting? It's how do I write that? Just 12 less. How do I just write 12 less? There's your mistake. I mean, what you said there was perfect. But notice that's different from what you said. That is the issue, and that is the problem that, I mean, I guarantee you other people had that same mistake. If you wrote 12 minus g, guess what you really just wrote? What do you really just subtract? If you wrote 12 minus g, guess what you're subtracting? You're subtracting g, right? It doesn't say g less than 12. It says 12 less than g. So 12 less than can only be written as minus 12. Therefore, the g has to go on the other side. So she's not going to make that mistake again because she just made a mistake in front of the entire class. There's some of you out there that didn't get that opportunity that will always mess up subtraction for at least 2 years. So try to learn from that. Thank you for making that mistake. Try to learn from that mistake. Cool? All right. Let's do these together. These are a bit more challenging. Here we go. Let's do the first one. This is box 4. The quotient of a number y divided by 10. Okay? Luckily for us, division, you write it exactly the way it reads, right? So you see, as you see the word quotient, that means division. You're going to have 2 things. You just write it exactly the way it appears. So this would be y. And you could either do this with a division symbol or a fraction bar. There you go. I showed you both. Either one is correct. Yes? It's always the first thing, and the denominator is the second thing. Okay? That's why subtraction is the only one that people get wrong. 7 increased by number x. 7 increased by number x. What are we actually adding here? Are we adding 7 or are we adding x? Okay, I agree with that basic statement. But what are we adding to the other number? We're adding x to the other number. Well, that's only written as plus x. So this is 7 plus x. Once again, the commutative property saves your butt. Even if you make a mistake here, I technically give you credit for it. 7 plus x is the same as x plus 7. Yes.
So it's still okay to do x plus 7.
No, let's try to do it as it reads. Right? For this particular one, it mathematically doesn't make a mistake, but it's a difference. But as soon as we get to algebra 1, and what we're adding to it is kind of weird, right? I'm not saying it's going to make a difference, but we would like it to be exactly the way it reads. Addition is always commutative. All right, this is the hardest one. Who's the smarty pants that thinks they know how to do this one? You think so, Gavin? Let's see.
So 12 more than 3. And since it says more, then we know it's addition.
Okay, I got addition from right there. What does times mean?
So you have
How many operations are really going on here?
2.
2. So what do you think the answer is? Go ahead. What? Say that again? I'm doing a teacher thing. He's looking at me like, oh. So go ahead. Is he right? Okay, teacher thing again. This is how I gotta cause doubt in your brain somehow. I don't do that by saying, yes, good job, right? Yeah, he's right. It's 3m plus 12, or 3 times m plus 12. 12 more is plus 12. 3 times a number m is 3m. Push those two things together, and you get 3m plus 12. Next year, you'll see lots and lots and lots of these where there's 2. I don't think we ever do one with like 3 operations. Not this year. Yes.
So with this, so you take the so you would take the 3 and then the m and then put them together.
Because doesn't it say 3 times a number m?
Yes.
So could I put a dot there?
So you would do the 3. So you do the multiplication first when you're writing.
Remember by PEMDAS we'd have to, sure. Okay. If you put a dot there or parentheses, you're fine. Just remember when we have a number and a variable, the easiest way to show that they're being multiplied together is just squeeze them together. Okay? And you're comfortable with that by now. All right, do I have to say it for a 4th or 5th time? Which one do you have to be careful with? Subtraction is the one. 5 less than n. How do we write that? Don't you really want to say 5 minus n? Because that's the way it reads. 5 minus n. It literally almost reads that way. But 5 less doesn't mean 5 minus, it means minus 5. So that one's n minus 5. N decreased by 5. So now we have people that are, well, I saw a pattern, you just flip them around, and then you read something where they're not flipped around. It says decreased by 5. Something decreased by 5 is minus 5. This was one of the few times where it literally is exactly the way it appears. Decreased by 5 would be minus 5. 5 less than is also minus 5. Notice on both of those examples there, one follows the pattern, one doesn't. So which one do you need to be careful with? You got to read it carefully and closely and slowly. Subtraction will kick your butt. Yeah. Okay, I want to set myself out on a limb there and say always just read it carefully. Try not to set up rules for subtraction. Read it carefully. In this case, you're correct though. All right. The more challenging ones, oh, look at all those words. Look at all those words. It's the same type of problem. They just put more, I don't know, more story to it, more words. It's just as easy. There's just more words to read. All right, let's see. This is box 5. The number of hours in W workdays if each workday consists of 8 hours. Oh, wow, that's a lot. The number of hours in W workdays. What's my variable here? W. Each workday is how long? So guess what they want you to write? W times 8 or 8 times W. That's the whole darn thing. So you tell me, was this one complicated?
No.
Or are they just trying to make it complicated?
They tried
They are trying to make it more complicated. Look at all those words. Yes.
I think it's the way they worded
And oh, by the way, it has some really crazy hard, the way they worded it, you know, probably they could have done a better job at that as well too. So don't be intimidated by these. Yes.
So in this one, do you want us to put how the order of the goal?
Yeah, and I'll just say, remember, multiplication is commutative, right? I did, and you know, I apologize for that. I'll just say we are pretty much for multiplication of a number and the variable. You'll learn later, not this chapter, but we generally tend to put the number first, the variable second. That's only for multiplication. Anybody know what the A is called? It's called something called coefficient. All right, we'll talk about it later. All right, box 6, a few fewer words. The total value in cents of Q quarters and D dimes. I told you word problems, there's 2 times you got to pay attention. The first one involves time, and the second one involves,
Money.
we got money, be careful. Does it say dollars or does it say cents?
Cents.
Okay, if it says cents, we don't have to put decimal places. If it says dollars and you're dealing with cents, you got to put decimal places. Did I lose anybody there? Okay, so luckily for us, it says cents. How many cents in a quarter? How many cents in a dime? Okay, just checking. Now this should be like 3rd grade or something, right? What am I going to write here?
25.
All right, 25 plus 10. Is that kind of the whole problem? Oh, there's variables up there. So if I have 4 quarters in my pocket, what's that math there? Yeah, agreed, but what's the math? 25 times 4. So this math actually involves, but it says the total value, so therefore it also involves, you got it, good job. So this is going to involve both multiplication and addition. So who's got it? Who's the smarty pants out there that's got it? Anybody want to take a guess? Go ahead.
Okay. U times
So if you do Q times D, you're multiplying the dimes times the quarters. If I want to count up the amount of money in my pocket, I got quarters and dimes, would I multiply the number of dimes times the number of quarters? No, that doesn't make sense. Who can help us? What do you got?
You would add the number of quarters and dimes and then multiply.
Okay, so if I have 1 quarter and 4 dimes, I'm going to write 1 plus 4, and then I'm going to multiply by what? Well, now I got a mixture of quarters and dimes, right? That doesn't make sense. What should I do? Well, let's just think about it. All right, I got change in my pocket. Forget about the problem. I got change in my pocket. I reach down in there. I don't have any dimes or quarters. I should have for days. I put them on the desk. How do I figure out how much I got? Well, one way would be to separate the dimes and the quarters, 2 piles, and then what?
I don't think we have enough.
We have plenty of information, right? I have an unknown number of dimes and quarters. I put them on the desk, and I separate them into dimes and quarters. Then what? Then add what?
you add the dimes and then you add the
Oh, no. What would I do first?
You will count how many quarters.
I count how many quarters, and then what?
You count how many dimes.
No. Keep that thought. I count how many quarters. Then what?
Set back 25.
Well, then I don't know how much money I got. I count how many quarters. I got 7 of them.
And then you add them.
You
I
times
just-
7. You got 25 times 7.
Oh, so I take the number of quarters and I multiply by?
How do you know how many quarters?
I'm just saying in general, a general example. I count how many quarters and I multiply by?
7.
Why am I multiplying by 7?
Because you got
You just said you had 7.
7 times 7 is 49, so I have 49 cents, yes?
You
That didn't work.
times them by
I count, I got 7 quarters, now what?
times them by 25.
Is she right?
Yes.
Okay. So step number 1, I'm going to count the number of dimes and quarters. I've already done it in this problem. I got Q, and I got D. But then what do? I never add dimes and quarters. Why is that a problem if I add dimes and quarters?
You add the totals together.
Hold that thought. Why would I never add the total number of dimes and quarters?
Because they're not like the same.
They're not the same, right? They're different. One's worth 10 cents, one's worth 25 cents. Okay? So, I'm just saying, the easiest way is think about, you got a pocket full of change, you pull it out, you drop it on the desk, and the person says how much money you got. You're going to count, right? Count is a mixture of addition or multiplication. The smarter people do multiplication. They count how many quarters and multiply by. That's going to give you a number. Then they take the number of dimes and they. So how would I write that for this? He's saying it can't be done because he's looking for numbers. There's no numbers up here, by the way. Think about the scenario I just said, and what are we going to write?
Q times 25 plus 10 times D.
I think he's got it. right? I think he's got it, right? We know that a dime is worth 10 cents and a quarter is worth 25 cents. This time, we don't know how many we have, but we have Q quarters, and I should have wrote this backwards. Q quarters and D dimes. So all we have to do is literally what you just said. 10 cents times how many dimes we have, plus 25 times how many quarters. I think we need to do another one, yes? Yeah.
Can we put parentheses around this?
We could if we wanted to. Right. All right, let's do box 7 together. Uh-oh, we're dealing with money again. Are we dealing with cents or dollars? Okay, if we ever get cents in this, we got to use decimal places. If we just have dollars, we're okay. But if we have dollars and cents, we got decimal places to think about. The value of a $5 bills and 10 $10 bills. You tell me, is it the same or different as the previous example? It's the same problem, except they have dollars. Instead of dimes, you have. Instead of dimes, you have. Instead of dimes, you have.
Dollar bills.
You don't have any dollar bills. Instead of dimes, you have $10 bills. Instead of quarters, you have.
$5.
It's the same problem. So what's the answer? What do you think? Go ahead.
5 times F times 5.
Keep going.
F5 times 5 plus G.
Very good. Yes? Is that the same problem or different than this previous one? It's the same problem. This time we're just dealing with dollars instead of cents. Is this the same or different?
Same.
Kind of the same, except we're not dealing with money. Now we're dealing with time. The other thing we got to be careful with. The number of hours in S school days, if each school day is 7 hours long. What do you got?
X times 7.
Why?
Because it says each day 7 hours.
Because it literally says each day at school you're spending 7 hours. And how many days of school do you have? I don't know. It says S. So it's just 7 times S. We okay? All right. I've saved the hardest for last. Hardest for last. You really got to pay attention now. Have you ever heard the word consecutive number? Write this down. A consecutive number, we're just talking about whole numbers, that increase by 1. Somebody pick a number.
5.
5. What's the consecutive number to 5?
6.
And then,
7.
and then,
8.
we're just basically counting. Consecutive numbers. Whole numbers that increase by 1. So if I give you 8, what's the next 2 consecutive numbers?
9 and 10.
Anybody lost? Pretty easy, right? All right. We can also say, instead of what are the next 2 consecutive numbers, what are the 2 preceding numbers? So what are the 2 preceding numbers from 8?
7
And he was saying up here, I just want to make sure everybody's good. Are we good with what are called consecutive numbers? You're like, well, that isn't challenging at all. Oh, it will be. Now, put your thinking caps on. What number did we start with?
I'll put on my 10 point.
If you start with 8, how do we go to the next number? I just added 1. If we start with 8, how do we go to the 2 from it?
Add 2.
If we start with 8, how do we go to the preceding one? If we start with 8, how do we go 2 preceding ones? No one has a problem with that, right? That's pretty easy. Tonight for homework, they're not going to tell you what the number is. They're going to say, there is a number. What are the next 2 consecutive numbers? How in the world could you figure that out? So in math, when we don't know what the number is, we are going to,
Yes.
we are not going to guess, we're going to assign a variable. Now here's where you got to stay with me. Anybody lost so far on this? No one has ever lost. Now it becomes, if you're not paying attention, you will become lost. Tonight for homework, they're not going to tell you the starting number. That means you're going to assign a variable. It doesn't really matter what. Okay? So Here's how the question will read. Write a variable expression for the next 3 consecutive numbers if you start with T. So once again, let's go back to an example. If I start with 5, what are the next 2 consecutive numbers?
6, 7, 8.
No one will make any mistakes there. But that's really 5 plus 1, and the second one is really 5 plus 2. We're going to use this same model, except what number are we actually going to start with?
T.
So if we start with, oh, it says 3, sorry. So 8 plus 3. Sorry, 5 plus 3. So if we start with T, what's the next number? Well, how did you find it if I gave you 5? So what would the next number be?
T plus 1.
Is that any different than this? You take the number that you start with and you add 1. I took the number I started with, in this case it's a variable, and added 1. What's the second consecutive number?
T plus 2.
What's the third consecutive numbers?
T plus 3.
What's infinity times infinity? No,
Infinity.
we'll talk about infinity next year.
Double infinity.
So you tell me, this is weird, right? But when you understand what's going on, is it really challenging? It's really easy, but if you weren't paying attention, you won't get this tonight for homework. All right, we got to talk about the preceding numbers now. If I start with 5, what's the number that comes before it? Well, how did you get that?
Minus 1.
Okay, so you take 5 minus 1. Okay, 5 plus 1. There we go. Preceding numbers, it would be 4. That's 5 minus 1. So now I'm going to say we start with an unknown number.
7.
So if P plus 7 represents the number that we start with, give me the preceding and the next. So if this is what we start with, stay with me. What's the next number?
T plus 8.
P plus 7 plus
1.
sit and stop packing up. We will wait.
T plus
So the first consecutive number would be this plus 1. In other words, it would be,
T plus.
and for those of you who said, can we solve something? Well, we can't solve, but we can simplify this. That would be P plus 8. What's the one that comes before?
T plus 7 minus 1.
Which would be, all right. For those of you that you didn't intuitively understand that, remain in class, copy down this. If this just totally made sense to you, then you don't need to write it down. All right. See you tomorrow. Hey, and I still need to show you the homework slide, yes?
I got it
Oh, you did. Good.
done. I shall do my homework.
Make sure you ask me questions in student advisement if this was, you were sitting there and all you heard was blah, blah, blah. All right, e-learners, you have any questions, send me an email. I will see you guys tomorrow. I'll have your test graded by this weekend. So Saturday or Sunday is when, definitely by Sunday evening, you'll have the results of your test in PowerSchool. Cool, thank you.
Everybody,